Welcome everybody to the Advanced CRT Seminar Series. We are today joined with Dr. Mubashir Rehmani, lecturer at the Department of Computer Science in MTU, senior member at IAEE, and editor in other highly reputed journals. He was recently honored with the Clarivate Highly Cited Research Award in 2021 and 2020, ranking among the top 1% researchers in the field of computer science, and his work focuses mainly on computer science and cybersecurity, but also includes wireless communications, blockchain, and other networking and telecommunication related issues. Today, he is here with us to dig into the implications of blockchain and cryptocurrency for communication networks, and we're very, very grateful and pleased for hosting you here, Dr. Mubashir Rehmani. And without further ado, I leave the floor to you. In the meantime, I always remind to all the participants to switch off their microphones while the duration of the seminar. And if there are any questions, you can use the chat, and then at the end, there will be a Q&A. Without further ado, floor is yours, Dr. Mubashir Rehmani. Best of luck in the process.
Thank you very much, Luis. And thank you very much, Advance, for giving me the opportunity to share my thoughts on cryptocurrency. Can you see my screen?
Yes, we can.
Okay. So, and the slides are moving, right?
They are.
Okay. So today I'm going to talk about blockchain, cryptocurrency, and how one can use blockchain and cryptocurrency in communication networks. So before we further proceed, let me share you some thoughts about cryptocurrency. So cryptocurrency, when we talk about cryptocurrency, it's basically a computer-based digital currency, and as the name implies, cryptocurrency comes from cryptographic algorithms. And these cryptographic algorithms, basically, there are some cryptographic algorithms like encryption, digital signatures, and hashing. All these famous cryptographic algorithms are the integral part of cryptocurrency. That's why it is known as cryptocurrency. So these cryptocurrencies are generally managed through computer networks, which we know as blockchain, although there are other data structures on the basis of which one can manage the cryptocurrencies, but majority of the cryptocurrencies are based on blockchain network. And one of the unique feature of cryptocurrency is that it is not controlled by any central authority, banks, or governments, and we can buy these cryptocurrencies either from cryptocurrency exchanges, or we can earn these cryptocurrencies through the mining process. So when we go and look into the depth of these cryptocurrencies, as you can see, there are more than 17,000 cryptocurrencies exist today in the world, and these cryptocurrencies are decentralized, distributed in nature. So among them, these are few of the famous cryptocurrencies. Bitcoin and Ethereum are the largest cryptocurrencies, and that share around 60% of the market capital. So when we talk about market capital, basically we take the current price of the cryptocurrency, and when we multiply it with the circulating supply, we get the market capital. As you can see, Bitcoin and Ethereum, they have huge market capital, and around the globe, hundreds of thousands of people have invested and make investment and trading through these cryptocurrencies. There are some other cryptocurrencies as well, for example, Tether, XRP, Litecoin, Cardano, and there are others as well. You can see Bitcoin has a very high price. So I will be focusing majorly on Bitcoin and Ethereum in today's talk. So as you can see, this is the last 1 year data of Bitcoin prices. Here you can see back in July 2021, one Bitcoin was around more than 30,000 US$. And as you can see, in between October and November and December, the price raised a lot, and it went to more than 60,000 US$. And then, as you can see, recently, the price has again been very much volatile and has been decreased, and we can find the price of one Bitcoin around $20,000. So one of the question that people ask, why there are a lot of people investing and interested in cryptocurrency? The reason is simple. As you can see, let's say if someone buy one Bitcoin back in July 2021, it was worth $30,000. And after just waiting a couple of months, let's say 6 months or 8 months, one Bitcoin price was increased to $60,000. So within a few months, the person got a profit of $30,000. This is amazing, astonishing, and extraordinary return on investment that one cannot find in any other community or any other trade. And it's just because of few clicks on your computer and you are getting enormous amount of profits. That's why a lot of people they are investing in cryptocurrency. Now there is another side of the coin. Let's say if someone bought this cryptocurrency in October or November 2021, the price was around $60,000, and then right now the price is $20,000. So that person, within a few months amount of time, they lost more than $40,000. So there's both sides of the coin. That's why the cryptocurrencies, especially Bitcoin, is highly volatile and highly speculative, and there's a lot of risk when investing on these cryptocurrencies. This graph shows the last 7 days of activity of Bitcoin market. As you can see, in the last few days, the Bitcoin price has been increased a little bit, but still it is far much below than $60,000. Now there is another issue with Bitcoin in particular, and even in Ethereum as well, because right now Ethereum has not switched back to the proof of stake consensus algorithm. So both the Bitcoin and Ethereum, they are based on a mining process, which I will explain later. And this mining process is based on a consensus algorithm, which is known as proof of work consensus algorithm. So this proof of work consensus algorithm, it basically requires and consumes a lot of energy, electrical energy. That's why it is creating a lot of alarm in European Union and other countries as well. So why the question, why this much amount of energy is being consumed by Bitcoin and Ethereum? The reason is miners. Basically, whenever you make a transaction, those transactions are bundled in the form of blocks. And since there is no centralized entity in a Bitcoin network, therefore miners, they participate in the validation and consensus process, and they try to mine the block. And all the nodes that are participating in the mining process, they are free to involve in the mining process, and they consume a lot of energy. So when we talk about consuming energy, there are 4 main factors that impact on the energy consumption of the cryptocurrency mining. The first one is hardware computing power, how much heavy device you are using. The second one is network hash rate. So hash rate basically how many calculations can be performed per second. So the higher the computer specifications you have, and the higher the hash rate you have. And the hash rate, the network hash rate, is adjusted in Bitcoin blockchain after a few weeks, so that those who have higher computing power and resources, they cannot easily mine the block. There is another factor which is known as difficulty. Difficulty is again increased by the Bitcoin. So difficulty is a measure of how difficult it is to mine a Bitcoin block, or in more technical terms, to find a hash below a given target. And then there is a thermal regulation of the for the hardware. And when we talk about Bitcoin mining pools, there are other aspects as well, like providing cooling to the mining pool, and other basic civil engineering energy consumption requirements of the buildings. So all these factors make the energy of the Bitcoin network so much high that it is too much alarming. So here you can see this is one of the device. It's like a CPU, and it's a dedicated device which we known as Antminer. And this is S19 Pro Bitcoin miner, and it cost more than $5,000 US, and it is specifically designed to mine Bitcoin block. So if someone is able to mine a block, they will get a reward in terms of mining and in terms of transaction fees. So the miner will get two rewards: the transaction reward and also the mining reward. And these are very huge amounts. That's why people are more interested in the mining process. So if someone buy this Bitcoin miner S19, they need to spend more than $5,000 US, and then they can start mining the Bitcoin blockchain. But it is not guaranteed that even with this device you will be able to mine the block and earn the Bitcoin. The reason is that there are more powerful devices, and people are using different strategies so that they can easily mine the blocks. Even you can use your own computer as a miner, but the probability of successful mining will be less than even 1% to mine the block. Now here you can see this is a hydro container. This is capable of over 1 megawatt operating capacity, and it contains hundreds of these Antminer, built-in Antminer. And you can see the cost of this mining container is $111,000 US, which is a huge amount. And people around the globe, they buy such containers, they create mining facilities, and then they start mining the Bitcoin. And this is why these mining process requires a lot of energy. Now, how much precise energy they will be consuming? So here you can see this is the data that I have taken from the Cambridge Center for Alternative Finance, CCAF, which is a research center at the University of Cambridge Judge Business School. And they are trying to monitor Bitcoin electricity consumption. As you can see, they are monitoring it back from 2016. And as you can see, as the year goes on, the amount of energy electrical consumption has been increasing a lot. So here you can see this is the comparison of the Bitcoin electricity consumption with some countries, for example, Pakistan, Netherlands, Argentina, and UAE. So you can see alone Bitcoin is consuming a huge amount of energy as compared to these countries' annual energy consumption. So this is a very alarming situation because it is creating a lot of environmental effects as well. And especially European Union has a serious concern, and they are trying to think about making some laws to prevent mining within the European Union. Now, another thing that I want to share with you about Bitcoin blockchain is that basically blockchain is a decentralized distributed ledger, and the main theme or the main reason of bringing the concept of blockchain was to get rid from the third party, from the central entity. Now, when we look at the first implementation of blockchain, which is Bitcoin, we can see that in the mining process, there are few entities or few mining pools that control the whole mining process within the Bitcoin community. As you can see, there are these 6 mining pools. They dominate and they monopolize the whole mining process of the Bitcoin. So if these mining pools, they can easily overtake the whole Bitcoin regime, cryptocurrency, and they can even launch, if they combine together, they can launch 51% attack as well. And the main reason for coming up with these cryptocurrencies is decentralization. But as you can see, in implementation in real sense, we cannot find such decentralization in the current state of the Bitcoin blockchain. Now there is another research investigation carried out by a few researchers, and they try to, as you know, Bitcoin blockchain is publicly available and all the transactions can be tracked easily. So what they did is that for the first time when the Bitcoin was launched, they try to see how much a mining process has been carried out by a particular people or agents. So as you can see over here, in the first 2 years, there were only 64 key players who mined most of the Bitcoin. So they were the main owner of the largest cryptocurrency. And then basically, as you can see, as the time goes, that cryptocurrency get started and distributed among the people. But still, in the first 2 years, when this largest cryptocurrency emerged, there were only 64 people who were dominating and monopolizing the whole cryptocurrency Bitcoin. Now, Bitcoins came with the egalitarian promise, means the concept was that we try to get rid from the classical distribution of income inequality. But as you can see, there's a small fraction of miners that held most of the wealth and power, even in the current state of the Bitcoin. And these are scientific observations, results that are available in the scientific literature. Now, if you want to observe how exactly the whole mining process occur and which blocks are being mined, what is the current state of the mining process, what is the current state of the blocks, what are the current state of the transactions, we can observe it through some visual tools. This is one of the very good tools prepared by SystemX, INRIA, and University Paris-Saclay in France. They provide you an online tool, visual tool, where you can analyze which of the mining pools around the globe are participating in the successful mining of Bitcoin. What are their contributions, what payout schemes they are using, and how the hash rate is impacting on the overall mining process. So all of these can be visualized, and you can access this through the IP address that I mentioned over there. It's a very nice visualization tool to observe how things are getting evolved in the Bitcoin blockchain. Here is another online resource, ethstats.net. Here you can specifically observe how the Ethereum blockchain is getting evolved, how many blocks have been mined and became the part of the blockchain, what is the average network hash rate, what transactions are there in the pool, what are the uncle count and difficulty and block time and gas spending, and all these statistics they are available in this online portal. So this was a little bit introduction about cryptocurrency. Now we can see there's a huge amount of investment and capital, market capital of these cryptocurrencies, and people have some concerns as well for these cryptocurrencies. But the underlying technology for these cryptocurrencies is blockchain. So when we talk about blockchain, so blockchain is basically a distributed ledger system, and majority of these cryptocurrencies, Bitcoin, Ethereum, and other cryptocurrencies, they are based on this blockchain. So blockchain is basically a distributed ledger that is structured into a linked list of blocks, and each block contains an ordered set of transactions, and this distributed ledger has been placed in all the nodes participating in the blockchain network. And we use cryptographic hashes to link and secure all the data in these blockchains. So whenever you make a new transaction and people add new transaction, those transactions cannot be deleted or modified. That is one of the unique feature of blockchain. So when we say that blockchain is a distributed ledger, so what is a ledger? A ledger is basically a principal book or computer file where we record some information. So there can be different types of ledgers. There can be a sales ledger, purchase ledger, general ledger, recording different information of our daily life or businesses or transactions. Now, historically, people save records manually on registers. Before the arrival of computers, before the arrival of internet, there were assets like land record or any other records. They were manually managed through the registers and copies, and they were recorded manually. But with the arrival of computers, these records were then moved on computers, and people start using Microsoft Excel or word processing softwares or normal databases like Microsoft Access or other databases. But as the time goes on, we have more sophisticated database management systems to manage those records, and then we had these database management systems. So these database management systems typically they are centralized. They are centrally controlled. For example, when we talk about a database of MasterCard or Visa card or any bank, they are controlled by a central entity, and the central entity server is managing and approving all the transactions. Then, as you can see, in the traditional database or in the traditional system, we have the central entity or central device that is controlling and manipulating all these records. So how to get rid from that? So that's why we have these the concept of blockchain, where we don't have any central entity, and the devices themselves reach to a consensus and then add a particular transaction to become the part of the ledger. Now let's take an example. When you look at transactions in traditional banks and blockchain, so here you can see, let's say Alice, she wants to send some money, let's say $1,000 to Bob. So Alice will try to access her account, and she can access it by the username and password provided by the bank. And once this request of making a transfer of $100 from Alice to Bob received by the Alice bank, Alice banks will first check whether Alice account contains this amount or not. If yes, then what will happen is that Alice bank will decrease the amount of $1,000 from the ledger of the Alice banks, and then issue a command to Bob's bank that transfer this $1,000 to Bob's account. Now in between we have central bank. So the central bank will be responsible for settling down any dispute between these parties, Alice and Bob, or any bank, and they will be serving as a regulatory entity. Now once the command will be received by Bob's bank, the Bob's banks will include this $1,000 in the ledger against Bob's account. And finally, when Bob's try to access his account, he can now see $1,000 in his account. So here you can see the whole transaction in the traditional bank has been carried out, and this transaction basically was controlled or managed by the banks, and banks were responsible for checking the identity and amounts, relevant amounts and balances in Alice and Bob's account, and they were responsible for making the ledger, state of the ledger update. Alice or Bob's cannot themselves update their own ledger. Instead, they were accessing the ledger, bank's ledger, their relevant bank ledger, through the username and password provided to them. Now, in the context of blockchain, what will happen is that Alice, the sender of the money, will send the amount of money to Bob, who will be receiving the money, but actually there won't be any central entity. So when there won't be any central entity, then the state of the ledger will be updated by all the participating nodes around the globe. So first, in the blockchain context, the complete copy of the ledger will be available to all the participating nodes in the blockchain network. And then once Alice make a transaction, that transaction goes into the mempool, and then any miner node randomly selected around the globe, they start gathering several transactions, make a block, and try to solve the mining puzzle. And once the miner wins the puzzle, that miner will broadcast that block to all the participating nodes in the blockchain network. Now, one important aspect is that here each participating node in the blockchain network will have the complete copy of the ledger. However, in the previous example, in the bank's example, only the bank has the copy of the ledger, and bank has the right to make any modifications or deletion or insertion of amount in the ledger. But in the case of blockchain, each node, each computer, each participating node in the network will have the complete copy of the ledger, and it's the mining process that will ensure that no one can falsely fabricate in their own copy of the ledger. So the mining process ensures trust in this trustless environment, and the mining process ensures that this blockchain network will work successfully. Now, when we compare this Bitcoin cryptocurrency model with the banking model, so we can see that in the banking model, we have the central bank that serves as the regulatory body, or it oversights all the transactions. In the Bitcoin, it is a consensus algorithm, or the Bitcoin protocol, that runs the consensus algorithm that ensures all these transactions are happening in a correct way. And the transaction verification is done centrally. However, in Bitcoin, this transaction verification and validation can be done through consensus algorithm. In Bitcoin context, it's a proof of work consensus algorithm. In banking model, money is created through loans. In Bitcoin, typically it is done through mining. So when all the Bitcoins will be mined in tens of years, then only there will be the transaction fees remaining that will motivate the miners to mine the block and to become participate in the blockchain. The value of money is basically the exchange rate, and it's the government or the central bank that ensures the value of the money. In Bitcoin, it's the trust, it's the demand and supply of the Bitcoin itself that impacts on the value of the money. There are transaction delays associated in the banking model, and typically when you make a cross-border transaction, it takes few days to completely settle the transaction. However, in the Bitcoin, it takes a few minutes to make such transactions. However, in the current existing deployments of blockchain, we have scalability issues. For example, when we compare the number of transactions that are being handled by Visa or MasterCard, they are quite enormous as compared to Bitcoin blockchain. So still there's scalability issues, that how these Bitcoin networks can handle such huge amount of transactions. Now in a blockchain network, this is a typical structure of a block where you have different blocks containing multiple transactions. So these transactions can be of the amount of Bitcoin you spend, or if you are talking about any other blockchain, you can include any other type of transactions or data in each of these blocks. So each of these blocks will be linked together through the hash value of the previous block, and the block will contain two main information: the block header, which contains some metadata about the block, including block number, previous hash value, or the hash value of the current block. And then you have the data transactions. Data transactions contain all the information, all the transactions that has been done in that particular block instance. And the first block of any blockchain is known as the Genesis block. Now, one question that may arise in your mind is that how this blockchain differs from database, or these distributed ledger technology differs from databases. So basically, you can consider distributed ledger technology as a database, but it is a decentralized database, or a recording procedure which doesn't require any central entity. So in both the database management system or in distributed ledger technologies, we have common records. However, in database management system, typically we have a centralized entity, but in distributed ledger technology, we don't have a central entity. In DLTs, we achieve consensus through mining nodes. However, in database, we have the central entity that dictates all the procedure. Both have the global view, and both can be distributed, but the main control in database will be by some approved central entities. There are some more differences between blockchain and database management system. The first one is hashing. So in database management system, we don't use hashing. However, in blockchain, we use heavily hashing, and it is the hashing that makes the blockchain system much more secure, and we use hashing in different points in the blockchain. We also use encryption, public-private key, which is not generally used in database system. However, it is essential requirement in a blockchain system. In database management system, we don't have the sequence of records. In blockchain, the records are appended in a sequential order, and the last record will be appended at the end. We have consensus algorithm that is not required in a database system, but in blockchain, it is an essential requirement. There is another feature which is immutability. The blockchain records are immutable. It means no previous entry or transaction recorded in the ledger can be modified. So this is one of the unique feature of blockchain that makes it unique as compared to the database system. And finally, the ledger dissemination. Since blockchain is publicly available and one can audit all the transactions, so the ledger will be disseminated to all the participating nodes within the blockchain network. Now, there are some vital characteristics of blockchain that makes it unique as compared to the existing database management system. The first one is decentralization, means there will be no central entity that controls the blockchain. Transparency, anyone can track the transaction history and track transactions. Transaction cannot be changed or tampered. Transaction cannot be disowned by the blockchain nodes, and one can easily audit any transaction within the ledger. Now, one of the first implementation of blockchain was Bitcoin. As you can see, back in 2008, Satoshi Nakamoto published Bitcoin's white paper, and then we had the first implementation of blockchain, which was Bitcoin blockchain, and it was created in 2009. And then as the time goes, we have a unique feature of a smart contract, and then we had this Ethereum blockchain having the smart contract feature back in 2013, and then blockchain trial was initiated by Nasdaq, and Hyperledger project was also started, and then there are a lot of developments within the blockchain technology area. Now, if we want to compare blockchain in terms of how it operates, we can have three types of blockchain systems: public blockchain, private blockchain, and consortium blockchain. Now, typically when we talk about Bitcoin blockchain or Ethereum blockchain, both of these are public blockchain, and they are completely decentralized theoretically, and one can easily access all the transactions and all the records of these public blockchain networks, and anyone can become the part or leave the network as they wish. Then on the very extreme, we have the private blockchain, which is completely centralized. So the question arises, why we have this private blockchain? So basically, it's almost same with the database management system. But in private blockchain, we have this hashing facility, digital signatures, encryption, and all other processes that some people try to prefer private blockchains. And then we have this consortium blockchain. Consortium blockchain, they are partially centralized, and there's a consortium of companies or organizations. They try to control the blockchain network. Now, in terms of layers, normally people who work in computer networks, they know about TCP/IP model or OSI model. So they think about a computer network in terms of layers. Similarly, we can also think about blockchain system in terms of layers. So we can have multiple layers in blockchain system. So the lowest layer is hardware layer, where we have the underlying hardware which runs the blockchain network. It includes CPUs, GPUs, etc. Then we have the data organization and topology layer, which looks after the data structure, data ordering, and other issues. Then we have the network and operating system layer, which looks after the communication mechanism, peer discovery, routing, and all the networking aspects of the blockchain network. Then on top of that, we have consensus layer, which is responsible for making consensus within the participating blockchain network. Now, depending upon the type of the blockchain network, we have multiple types of consensus algorithm. Proof of work is one of the famous. Then we have proof of stake. We have Ripple, PBFT, BFT, and there are tens of consensus algorithms right now available in the market. Then we have the visualization and smart contract layer, where we have compilers, distributed virtual machines, and all this stuff. And then on the very top, we have the application layer, where we can use different types of applications in the blockchain network, including cryptocurrency, distributed applications, 5G, record management, etc., etc. Now in Ireland, blockchain is flourishing a lot, and there are a lot of stakeholders, a lot of companies, organizations, and even in the education sector, they are investing huge in blockchain education and blockchain awareness. So these are few of the fintechs and social companies and mobile apps and insurance companies that are participating within blockchain landscape in Ireland. Now, as I have discussed in detail about cryptocurrency and blockchain, now I want to discuss how we can use these concepts in communication networks. So I will go very quickly. So when we talk about communication network, we can have two types of communication networks: wired networks and wireless networks. Wired networks require some sort of wired medium, including Ethernet, LAN, or fiber optic, and wireless networks, they require, they doesn't require the wired medium, and it includes mobile phone or Wi-Fi. So when you look at the wireless standards, so you may have used different wireless networks, including radio network, or television network, or mobile phone network, or Wi-Fi. All these they use on a certain frequency band, and some of them are only for outdoor, and some of them works both indoors and outdoors. But the unique feature is that any of these wireless networks, they use wireless radio spectrum band for their operations. So when we look at this wireless radio spectrum, it is in fact a natural resource like other natural resources like oil, gas, and minerals. So this wireless radio spectrum can be classified into licensed band and unlicensed band. The Wi-Fi we use it for 2.4 gigahertz, and it's typically a free band, unlicensed band, and anyone can use it. But the licensed band, they are owned by the companies, telecom companies, and other organizations that operate their network on the licensed band. For example, few of the TV channel operators, they get the license from the government to operate their TV channels. Similarly, FM radio channels, they also get their network operated by getting license from the government. And similarly, when you talk about different mobile operators, they also get license from the government to establish their network and to operate their network. Now, this wireless radio spectrum, as you can see, ranges from kilohertz, megahertz, gigahertz, and terahertz. And these different colors shows how this wireless radio spectrum has been assigned to different operations, including TV network, satellite network, Wi-Fi network, or mobile communication network. And this is the wireless radio spectrum map of USA, which is managed by FCC. The same thing we can see with UK. So Ofcom is responsible for managing the wireless radio spectrum. And here, this is the wireless radio spectrum map managed and prepared by Ofcom. So different color shows different assignment of this wireless radio spectrum. For example, you have maritime usage, aeronautical usage, mobile and wireless broadband usage of the wireless radio spectrum. Now, one of the issues with this wireless radio spectrum is that the wireless radio spectrum is basically scarce. And due to this fixed spectrum assignment policy and limited available spectrum in today's wireless network, there is inefficiency in the spectrum usage, as can be seen over here. So the idea was to fill those gaps and try to use the wireless radio spectrum efficiently and easily. So for that, we have the concept of cognitive radio. A cognitive radio is an intelligent radio that tries to identify these gaps in the radio spectrum and then try to utilize the unused portion of the wireless radio spectrum. Now, I'm aware of the time limit, so I just go to the very end of my presentation, how we can use the blockchain in the communication networks. So there are multiple usage of blockchain in communication networks. For example, we can use in green IoT for secure wireless power transfer. So when in the context of green IoT, it may be possible that some malicious nodes may steal some wirelessly transferred energy by declaring themselves as legitimate node. So how to track those energy resources? So all this can be done by integrating blockchain in green IoT. Similarly, in multimedia networks, if you want to check the integrity of the video or try to track fake video, you can also use blockchain. You can also use smart contracts for video content, peer-to-peer video content sharing. In Wi-Fi network, one can use blockchain for congestion avoidance and anonymous access control. How you can do, basically in Wi-Fi, the authentication is provided by Radius server, which is remote authentication dial-in user services. So if you use a blockchain network for authentication purpose instead of Radius, that can also be done, and there are people who have proposed such an idea in the literature. Similarly, in cellular networks, we have roaming. So in roaming, we have the home country and the visiting country. So whenever someone try to visit any visiting country, both the mobile operators, they interact with each other, and then there's a there's an agreement between different mobile operators among the home country and visiting country. So all this can also be done through blockchain, and blockchain can provide some benefits in this context. Similarly, there are many other use cases of blockchain in different communication networks. In cognitive radio network, more precisely, if you want to perform trading of wireless radio spectrum, then that trading can be done through blockchain network. So that's all for today's presentation, and I have very quickly passed to the applications of blockchain in communication networks. But if you are interested, you can go and look at one of my books which talks about blockchain and communication networks. So thank you very much, and if you have any question, you are most welcome to ask. So any questions? Okay, let me.
I think Evelyn Novayo has a question. Dr. Mubashir. So Evelyn, go ahead. Yeah. Switch on your microphone.
Can you hear me?
Yes.
Yeah, we can.
All right. Thank you very much for the presentation. It was very educative. I just want to quickly ask a question regarding the use of other technology in collaboration with blockchain, for instance, IoT and AI. Blockchain is notorious for being very slow. So how can, and of course, you know yourself, IoT generates a lot of data. If you have to combine IoT with blockchain, how can you use AI or machine learning to see how to reduce the latency? Is that possible to apply AI in this regards?
Yes, thank you very much for this question. So in the context of IoT, definitely IoT is generating a lot of data, and the IoT devices, they are energy and resource constrained devices. So we cannot use the same consensus algorithm and same architecture for IoT devices. So researchers are working on it, and they are designing new types of consensus algorithm, lightweight consensus algorithms that can meet the energy and resource limitation requirements of IoT devices. Moreover, one of the features of blockchain is that the copy of the complete ledger should be stored in the node itself. But in the context of IoT devices doesn't have that much huge amount of memory. So they are looking for different types of storage techniques or other techniques, how they can design architectures to consider the resource limitation and memory limitation of IoT devices. Now, as far as AI and machine learning algorithms are concerned, yes, it is being used, for example, in the context of Bitcoin blockchain. People have used machine learning algorithms to identify any anomalous behavior in the Bitcoin transactions. Some people have used to track transactions history by using machine learning algorithms. So AI and machine learning algorithms can also be used in conjunction with blockchain. And there are few researchers. They have published some work on this area, and if you like, I can point those names to you later on. Okay, any other question?
I think Ramin had a question as well, Dr. Mubashir.
Yes.
Ramin, can you unmute yourself and ask that question?
Okay, sorry, I wasn't able to unmute, just I got it. Thank you, Dr. Rehmani, for this seminar. My question is, with the emerging of the quantum computers and the quantum computing, would they be a danger or be a hazard for the blockchain networks? As we know, the assumption of the security assumption of the blockchain network is that it is impossible to have a node with a 51% bigger than 51% computational power than other nodes in the network. So by emerging the computer quantums, how we can regard blockchain network as a safe networks?
Yes, this is one of the concerns raised by a few researchers around the globe, that with the emergence of these quantum computing devices, we may not be able to securely secure the blockchain system. So the issue is with the hashing algorithm. So right now the hashing algorithms, they are the building blocks of blockchain network to make blockchain network secure. But with the emergence of quantum computing, one day we may have such quantum computing algorithms that may, overcome the existing hashing algorithm. Then in that case, of course, there may be some security challenges and issues in the current blockchain systems. And yes, this is one of the concerns.
I believe that there is another question in the chat. Dr. Mubashir Rehmani. Khadija Hafiz asked a question in there, so maybe you can read it out loud and answer the question.
Yes, so with Khadija asked, with proof of stake algorithm, is there a trust trade-off as compared to proof of work? Trust trade-off. So basically, when we look at the underlying principle of proof of work, it is based on solving a cryptographic puzzle, and the node which has the higher computational power will be able to quickly solve the puzzle. Now, in the proof of stake, we don't have that feature. In proof of stake, the node who has the higher stake will be able to mine the block. So that's why Ethereum is moving from proof of work blockchain to proof of stake, and it will reduce enormously the amount of energy of the Ethereum blockchain. So that is one thing. The second thing is that as far as trust is concerned, so again, the mining pools issue is still there, and the mining nodes, they try to monopolize the whole blockchain network, whether it's Bitcoin network or Ethereum network. So that trust issue may be a problem. I'm not sure if I completely get your question in terms of trust. So if I didn't answer your question completely, you may ask in more detail your question, Khatija.
I think there is another question, Dr. Rehmani, from Patrick O'Toole.
Yes, so we have a question from Patrick.
Yeah.
How do you see the future of cryptocurrency and blockchain? He said, I feel like they need to tackle the energy issues and how they can make it green and within climate goals before adopting it to new areas. Also, the whole NFT and Web3 hype by some people seems to be inflating the market and making it look like a bit of a pyramid scheme. So you are right. There are issues with the cryptocurrency in terms of energy, And that's why the Ethereum blockchain owner, or Ethereum itself, try to move from proof of work to proof of stake, and they will be shifting it in the next few months, I think, from proof of work to proof of stake. So it will enormously reduce the amount of energy consumption of Ethereum blockchain. The second thing is that definitely NFT is also based on Ethereum blockchain, and the whole hype is because of people who are buying NFTs, and they are trading, selling and buying all these NFTs through these cryptocurrencies. So that's why we can see the hype in this. So in terms of future of cryptocurrency, basically cryptocurrency is one application of blockchain, and I can say that there are 80% or 90% more other applications where one can use blockchain system. So if cryptocurrency itself is not 100% adopted by the governments, then even blockchain system it can be used in different applications. So I can see a future of blockchain, but as far as cryptocurrency is concerned, I am a bit concerned, because there are some initiatives by the European Union or UK. They are launching their own digital currencies. For example, UK, they are launching central bank digital currency. In EU, they are launching digital euro. So both of these initiatives may undermine the true potential of cryptocurrency. So any other question? Any other question?
I don't think there are more questions, Dr. Mubashir Rehmani. Thank you very much for your time. I don't know if you want to say something to close the session.
Thank you very much, Luis and Advance, for giving me the opportunity to talk on these topics. And thank you very much for listening.
Yeah. So thank you for your time and for this interesting talk, Dr. Mubashir Rehmani. We will be sharing the recording of this session, as we always do. And we remind all participants that the online Advanced CRT online seminar series takes a break now for the summer, and we will be back in September. In the meantime, if you need to follow up with Dr. Mubashir Rehmani, you know where to reach him. And thank you very much for your time, and I hope you have a good afternoon, evening. Bye-bye.
Thanks. Bye. Bye.